Good evening, students. So yesterday we have seen some problems in the differentiation, vector differentiation. Okay. So in that first order and second order and third order, we have seen some of the problems. So even I have told the concept of the partial differentiation for the vector functions. That is, if like this, any problem is given, if f is equals to cos xy plus 3xy minus 2x square into j minus 3x plus 2y into k. Okay. Then find first one is dou f by dou x. Okay. Second one is dou f by dou y. Next, third one is here only two variables are there, x and y. If one more variable is there, then we have to find the dou z by dou x. So here only two variables are there. Therefore, only we need to find the, that is with respect to of x and y. Okay. So partial differentiation, we know that we'll do with respect to of x and y. So dou f by dou x, dou f by dou y, and after that dou square f by dou x square, and fourth one is okay, now you are able to see that is 3x plus 2y, last one. Okay. So dou square f by dou x square and also dou square f by dou y square. Next, fifth one is dou square f by dou x into dou y. Okay. So these values we have to find from the given function. Okay. So dou f by dou x means with respect to of variable x, we have to find here the differentiation. That is a partial differentiation. Partial differentiation is nothing but with what variable we are doing the differentiation, only that variable term you have to do the differentiation. Okay. So here cos xy, two are there, y is there and also x is there. So you do the cos differentiation, that is the minus sin xy I, and here x is there and also y is there, two are there. So x differentiation is 1 here. So we are writing it as, that is cos has become minus sin xy. So when you take here xy as a quotient, x differentiation is 1. So you will have here y. Okay. So minus y sin xy. We are not, if it is a normal differentiation, then we will do the UV rule. That is, we'll do with respect to of x and with respect to of y. But it is a partial differentiation. Therefore, only with what variable you are doing, that variable only you have to do the differentiation. Okay. So plus 3xy means x is the 1. So it is 3y minus 2x square means it is 4x. Okay. Next, minus of, here j is there. Okay. And here only this has the x variable, this has the y variable. So it will become 0. This 3x will become only minus 3k. Okay. Minus 3k. So this is the differentiation with respect to of x. Now if you do with respect to of y, again this cos will become minus, that is xy differentiation if you do means y will become 1, x you has the quotient. So minus x sin xy I here plus 3xy means y differentiation is 1. So 3x minus this only x square is there, y is not there. So it is only 3x into j. Okay. So next minus 3x is 0, 2y is 2. So minus 2y into a. Okay. So like this you have to do the partial differentiation. Next dou square means for this one if you do one more differentiation it will become the second order. So minus, so with respect to of x square no, minus y will be like that only. Here sign will become minus, okay, or you write y afterwards, sign will become cos x, y is there, x that it will become cos x y I. Here one y is there, again one more y you will get, so it will be minus y square. Okay, after that plus 3 into y means it is 3 and here x is there, therefore its differentiation is 0. So there you have only constant term will become it as a, sorry, here this 3y will become 0, x differentiation we are doing now. So it is minus 4j. Okay, minus 4j. Next when you do with respect to of y, this one, so minus x, that is minus x, keep like that only, sign will become cos x y I differentiation, and here again y whatever it is there, it will become 1, one more x will be there, x into x is x square. Okay, now this is whatever you have 3xj is there, means here y term is not there, so it will become 0. So only this is minus, so minus 2 y will become 1, so it is minus 2. Okay, dou f by dou y, so sin will become dxj. So it is here. See here dou f by dou y, cos x has become minus x sin xy plus 3xy differentiation is 1, so only 3xj. This is 0 minus this is 0, so minus 2 y differentiation is 1 no, so only 2k will be there. So whenever 2k is there means this is 0. Why? Because it is the constant term no. So only dou square f by dou y square value is minus x square cos xy into I. Okay. Now whenever we'll do this one, we'll write this as dou by whatever the first differentiation is there, that is dou by dou x into dou f by dou y. Okay. That means dou by dou x of, what is dou f by dou y value? Dou f by dou y value is minus x sin xy I plus 3xj minus 2k. Okay. So minus x sin xy I plus 3xj minus 2k. Now you have to do the differentiation of this dou f by dou y with respect to of x. So wherever x terms are there, you do the differentiation of the term. So this is minus, sin will become cos, it is xy. So x differentiation will become 1. So you will get here minus xy. Minus xy. So minus xy cos xy. And this is with respect to of x means it will become 1. So it is plus. Okay. So this is the answer for the dou square f by dou y by dou x. So just you have to split this one, dou by dou x into one more dou will be there, no, that is dou f by dou y. So if you take dou by dou x outside and if you write the dou f by dou y value, so this is the dou f by dou y value, no, minus x sin xy I plus 3xj minus 2k. Okay. So now whatever this term is there, you are doing with respect to of x. Okay. That means sign will become cos xy. X will become 1. So y will be there. So minus xy cos xy. 3 into x differentiation is 1. So 3j. And this is the constant term. So it will become 0. Okay. So like this, we have to find the partial differentiation. So by this, we are completing the unit 3, unit 2. So now we will go to the unit 2. That is the unit 3. It is the gradient divergence and curl operators and their algebra. Okay. So curl and these all definitions are very important, and how they are defined, that are useful for solving the problems. So unit 3 is about unit 3. First one is the gradient of a scalar point function. Of a scalar point function. So how the gradient is defined. So if you see the definition, the gradient of pi denoted by grad pi or del pi is defined as, so definition you have in your textbook, it is denoted as, this gradient is denoted as grad of pi or del of pi. Okay. So, and it is defined as, so that is del pi, or we can write it as a gradient of pi. It is I dou pi by dou x plus j dou pi by dou y plus k. Okay, this is the important one. So you should know the definition of gradient of a scalar function, scalar point function. Okay, del pi is equals to I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Okay, so we can write either like this also, I into dou by dou x plus j into dou by dou y plus k into dou by dou z, and you can write outside pi. So anything representation is, that is only this part will be del and this is the pi. Okay. So is a vector differential operator known as, we call it as a, this is del. Okay. Or we call it as nabla. Okay. So this is defined as del or nabla. Okay. So in many solving the problems, you get this one. So properties are there for the gradient. So first property is a scalar point function pi of x comma yz is a constant if and only if del pi is equals to 0. So a scalar point function is a constant if and only if del pi value is equals to 0. Then we call it as a constant function. Okay. So you have the linear property of the gradient is also there. You can see in the textbook it is there, properties are there. So just to go through those properties. One important one is directional derivative of a scalar point function. So on this also questions will be asked, 5 marks questions. Directional derivative of a scalar point function. Okay. So this directional derivative of a scalar point function, how it is defined, that is important for solving the problems. So derivative of pi in the direction of unit vector A, we write it as with respect to S. Okay, del of pi, that is d pi by ds, is equals to del into pi into a vector a. That is a unit vector. This is a cap we have seen. So directional derivative along x-axis will be there. Directional derivative along y-axis will be there, and also directional derivative along the z-axis also will be there. But the main, whatever the definition is there, that is d pi by ds is equals to del into pi dot vector a. So what is d pi by ds means, it is defined as dou pi by dou s I plus dou pi by dou s j plus dou pi by dou s k. Okay, this d pi by ds, this is the differentiation. This is the partial differentiation. Okay, so dd, I'm writing as the shortcut, that is the directional derivative along x-axis is equals to del pi dot I, vector I. Okay, or unit vector I we get that. So it is defined as I into dou pi by dou s plus j into dou pi by dou y plus k into dou pi by dou z into I. Okay, I cap. So here, whenever you do the dot product of this one, only I dot I will become 1. Other, whatever the other are there, j and k, they will become 0. Therefore, along x-axis will be only dou pi by dou x. Okay, and if it is along dd, along y-axis means here this whole thing into j will write. So it will be dou pi by dou y. If it is for the z-axis means dou pi by dou z. Okay, z-axis means dou pi by dou z. Okay, so like this, if you know the definition, the main thing is this one, how it is defined as a gradient of a vector, and another one is how directional derivative is defined along the vector, unit vector a. That is also important. Okay, so if you know these two definitions, with the help of that you can solve the problems. So one thing is finding the gradient of, that is gradient of the given function. So one example we are seeing for the gradient of a function. So first one, find del of y plus z x y z also. Okay. So gradient means how gradient is defined. Gradient is defined as, that is whatever the gradient is there, in that place you write I dou by dou x plus j dou by dou y plus k dou by dou z into this one, whatever it is there, that one. Okay. So now with respect to of this I dou by dou x plus j dou by dou y plus k into dou by dou z, you do the partial differentiation with respect to of that one. That is I dou by dou x into x cube plus y cube plus z cube minus 3xy z plus j into dou by dou y plus k dou by dou z into. Now, so here I you write like that only, vector I. Now it is with respect to of x. So x cube will become 3x square. This is 0, this is 0, minus 3. X value is 1, so it is minus 3 yz. Okay. Next plus j. So dou by dou y. This is 0. Y will become 3 y square minus 3x z plus k into here x cube y cube both will become 0. Only z will be 3z square minus 3xy. Okay. So this is the answer for del of the given function. Okay. If you want, you can take 3 common here for all 3 is there. No, that is it is equals to 3 into vector I x square minus yz plus j y square minus xz plus k z square minus xy. Okay. So this is the answer for this problem. Okay. So now you have one problem on even directional derivative is also there. That is find the directional derivative of x square plus y square plus z square along the vector j minus k at the point 1 comma minus 1 comma 2. Okay. Okay. So on directional derivative also you will get one problem for the 5 marks question. This is about the gradient of the vector. So gradient means if that del will be there, del is defined as I dou by dou x, that will be there. So remember that one for solving the problems. Find the directional derivative of x square plus y square plus z square along the vector j minus k. Okay. At the point 1 comma minus 1 comma 2. Okay, this is the point we have. At this point, we have to find the directional derivative. So we just now we have seen the directional derivative along the x-axis, y-axis, and z-axis. And if it is for the unit vector, then how it is there, that also we have seen. Okay, with the help of that formula, we have to find the answer. So let pi of x comma y comma z is equals to the given function is x square plus y square plus z square. Okay. So then del pi. So we are defining this as a pi function. So del pi is equals to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Okay. So that is here what we have this one. This is with respect to of that is I dou by dou x plus j dou by dou y plus dou by dou z into x square plus y square plus z square. If you do the partial differentiation of this one, x square will become 2xi, y square will become 2yj, and this will be 2zk. Okay. So this is the partial differentiation with respect to of x, y, z. So at point, what is given in the question, point is 1 comma minus 1 comma 2. At point, this is the x value, this is y value, and this is z value. If you substitute here, what you get? 2 into 1 I plus 2 into minus 1 j plus 2 into 2k. So 2 into 1 is 2i minus 2j plus 4k. Okay. So this is the value of del pi with respect to of the point 1 comma minus 1 comma 2. Okay. So here one more, it is there no in the along the vector. This is the given vector. This is the unit vector here. So given direction is vector A is equals to j minus k. Okay. So we know the definition of the unit vector. That is a cap is equals to vector A by modulus of A. With the help of that, we have to find the value of A. Unit vector in direction of A is equals to A cap is equals to, that is vector A by modulus of vector A. So it is, what is vector A? J minus K. By modulus of this one is quotient of J is 1, K is minus 1. That is 1 square plus minus 1 whole square. It is equals to J minus K by 1 plus 1 is 2. Okay. It is J minus K by root 2. So what is the definition for the directional derivative with respect to of the unit vector A? It is del into phi dot A vector. Okay. So directional derivative of phi along A cap is equals to, that is along A is equals to del pi into A. Okay. So this is the A value here we have. So what is the directional derivative we got? This one. Phi minus 2j plus 4k into A. What is A here? A value is j minus k by root 2. Okay. So numerators, you do the dot product. So what you will get here, I is not there. I into 0 means it will become 0. Next minus 1 is there. It will become minus 2. Next plus 4k and then minus 1 is there. So it is minus 4 by 2. Okay. So minus 6 by root 2. So here 6 we can write minus 3 into 2 by root 2. So it is equals to minus 3 into 2. We can write it as root 2 into root 2 by. So these two will get cancel. Answer is minus 3. Okay. So like this, we need to find the directional derivative of the given problem. Okay, first, whatever the given function is there, that function in some problems, he will mention the pi value. So if it is not mentioned in the question, then you can take whatever the given function is there, that function as a pi. Then you write what is del. Del is I dou by dou x plus j dou by dou y plus k into dou by dou z. And you substitute the pi value. So if you substitute the pi value and if you do the partial differentiation, you will get this answer. So if any point is given in the question, try to substitute that point here. Then you will get the del f value at that point. So after that, you have to see which direction is given in the question. So if you see the direction, we take the direction as vector A. So for that vector A, we find the unit vector. So unit vector definition is A cap is equals to vector A by modulus of A. Okay. So write that vector, and in the denominator, whatever the quotients of I, j, k are there, you do the square of them. Then you will get the value in the denominator. Okay. So after that, the main concept is finding the directional derivative of pi along A is equals to del f dot A. Del f dot A means that is a vector, whatever we got here, that vector. You can take it as a cap. Okay. So it is del pi into A cap. So here whatever the A cap value is there, you multiply with the this del f. So when you multiply that, whatever the I, j, k terms are there, they will vanish, and you will get the resultant as any scalar. This is the value you are getting now. It is the scalar function. Okay. So this is about the gradient of the vector. Next we have the concept of divergence of a vector point function. So how gradient is defined? Similarly, divergence is defined. Divergence is nothing but del dot f. So there del into pi was there. Here del dot f will be there. F is any function. It is defined as f1i plus f2j plus f3k. Okay. So next, divergence of a vector point function. Divergence of a vector point function. So f is defined as fni plus f2j plus f3k. Okay. So divergence of f is denoted as, so divergence of, so it is denoted by div f or del dot f. Okay. Like this, it is denoted and defined as del dot f is equals to, what is del definition? I by rho by rho x plus j by dot f. What is f? F is f1i plus f2j plus f3k. Okay. In place of f, you can substitute that one, and then you can find the partial differentiation of that one. Okay. So some important points are there in this notes. That is del dot f is not equals to f dot f. Okay. This commutative property is not satisfied by this one. And if C is a constant vector, then div of C is equals to 0. Okay. So for gradient, you will have the directional derivative, and here you will have the solenoidal. So a vector F, this is the important one. Okay. For solving the problems also, we will get a vector F is said to be a vector F is said to be solenoidal if div f equals to 0. Okay. If div f value is equals to 0, then we call that vector f as a solenoidal. Okay. So if you see one example problem, that is if r vector is equals to xi plus yj plus zk, find div r. So diver means equals to del dot r. What is del? Del is dou by dou x j plus k into dou by dou z. And what is r here? R is xi plus yj plus zk. Okay. So it is I into that is dou by dou x, dou by dou y. So xi plus yj plus zk. Now do with respect to of x. So I into I is 1. Dou by dou x of x means we will get it as 1 plus j into dou by dou y into this one means differentiation of y is 1. Next z is also 1. So this value is 3. Okay. So like this, if any function is given, you have to find the del of the function, that is called as the divergence of a vector. So next one is show that given vector f is solenoidal. That means you have to get it as a diverse value as 0. Then we call it as a vector function f is a solenoidal. Okay. Show that f is equals to yzi zxj plus xyk is solenoidal. So for that, to show that it is a solenoidal, diverge should be equal to 0. By definition of divergence, diverge is equals to I dou by dou x ij diverge. Okay. Those. Okay. So here directly we can write it as, here this is f1, f2, f3. So dou by dou x of, what is f1 yz plus dou by dou y of, what is f2 zx plus dou by dou z xy. Okay. This is x variable is there, but here x variable is not there. So this will become 0. Here also y variable we are doing, but the y variable is not there, so it is 0. Here also with respect of z variable, here z is not there, so 0. So this value is 0. So therefore, since diverge equals to 0, f is solenoidal. So like this, you have to find a problem. So in this only one more problem is there, that is if phi of x comma y comma z is equals to 2x cubed y square z to the power of 4, then find del dot del pi. Okay. So that is only one function is given pi, with the help of that. It is not the gradient of the vector. Divergence and the gradient both are included in this. Both combination it is given. We have to find the value of this one. Okay. So this is about the divergence of the vector function f. So if pi of phi of x comma y comma z is equals to 2x cube y square z to the power of 4. Then find del dot del pi. Okay. So first we will find del pi. I do by do x towards pi is 2x cube y square z to the power of 4. Okay. So now when you multiply this one and when you do the differentiation of this whole thing, this thing with this, so it is with respect to of x means here x will become 3x square. So 3 to just 6x square y square z to the power of 4 I plus y with respect to means 2 to the 4 4x cube y z to the power of 4 into j plus z means z to the power of 4 is there, that means 4z cube x cube y square k. Okay. Okay. 4 2s are 8. No, here this will become 8. 8z cube x cube y square. Okay, this is the del pi value. But in the question is asking del dot del pi. Again, del means same. I by dou x plus j plus k dou by dou z. Dot product of this whole thing. That is dot product of 6x square y square z to the power of 4 I plus 4x cube y z to the power of 4 into j plus 8z z cube x cube y square into k. Okay. Now we need to find the dot product. So I dot I will become 1. And with respect to of x means x square differentiation means 2x. So 6 2s are 12x y square z to the power of 4. Okay. So I will be not there. Next here with respect to of y. So y will become 1. So 4x cube z to the power of 4. Next here 8 with respect to of z, no. So 8 3s are 24 z square x cube y square. Okay. So this is the answer for del dot del pi. You can take here 4 common. You can take 4x y is not there. So we can take z square common from these three terms. So 4 3 is 12, x gone means it is y square, z square. Next here 4x, x is gone means x square, z square. 4 1 the 4, okay, 4 3 is 4 6 are 24, z square gone, 1 x is gone, so x square y square. Okay. So this, like this, we have to find the divergence of a vector with respect to of the given functions. Next, we have the concept of the curl of a vector. So we have seen gradient and also we have seen the divergence of the vector. Next one is the curl of a vector point function. So curl of a vector function is nothing but whatever the del is there with respect to of the del only will do. That is del cross f. So del cross is f is similar as a vector cross product we have seen. No? That is a cross b. How we will find the value with the help of that we have to find this one. So this is about the curl of a vector point function. vector point function. So definitions we have in the textbook. So f of x is a function. It is defined as f1i plus f2j plus f3k. Okay. So this is the function. It is defined. So then curl f is denoted as curl of f is denoted as curl f. Okay. Or we define it as del cross f. Okay. So curl f is defined as like this. Curl f is equals to del cross f. Okay. We write it as like this. Curl as a del cross f, and curl f is defined as del cross f. Okay. So and the value of this one is del cross f is equals to I j k and dou by dou x, dou by dou y, dou by dou z, f1, f2, f determinant. Okay. So like this, we need to find whenever curl of a vector is asked in the question. Okay. So and here one important note for this one is that if del cross f is equals to 0, when you do the cross product of this one, if you get the value as 0, then f is called as or we can tell f is said to be irrotational. Irrotational. Okay. There we have called it as a solenoid. Here we call it as a irrotational if del cross f is equals to 0. Next, one more we have concept in this, that is the Laplacian operator. Okay. Laplacian operator. On this also you will get the questions. So Laplacian operator, it is denoted by del square. Only del square it is defined as a Laplacian operator and defined as that is del square is equals to del dot del. Okay. Del dot del is called as a del square. So del square pi equals to 0. We call it as a Laplace equation. We call it as Laplace called as Laplace equation. Okay. So one more here definition is there. It is the divergence of gradient of phi is equals to, this also you remember. This note only will be there. Third one is divergence of grad of phi is equals to del dot del pi. So it is equals to del square into pi. Okay. So del square into pi, we can define it as divergence of gradient of pi. So find del cross f. One problem we are seeing. Del cross f, where f is equals to that is f of x comma y comma z is equals to x square y minus 2xz plus 2yz. Okay, 2yzk, this is the given function. We need to find the del cross f or curl f. So del cross f is equals to del cross f is equals to ijk by dou y f1 f2 f3. So this is f1 f2 and f3. First f1 is x square y and this is 2xz. Next it is 2yz. Okay. So now we have to find the cross product for this one. So how we will find the cross product? That is a determinant value we have to find. So it is equals to I into, that is dou y of, to eliminate this column and this row, dou y of 2yz minus dou z of minus, here minus is there. So minus of minus means you can write here plus, no need of writing nothing. Okay. Next plus k into this means dou y of 2y minus 2z minus of minus means so this means dou y of 2yz minus of minus is plus dou z into 2xz. Next minus j into, if you eliminate this column and this row, dou x yz minus x square y. Okay, so this is about y. Next, if we take k, if you eliminate this column and this row, dou x of minus 2xz minus dou y of x square y. Okay. Now we need to find the partial differentiation of this one. If you simplify that, you will get the answer. So it is equals to, you keep like that only dou y. Here only y differentiation means it will be 2z plus, it is with respect to of z. Z differentiation is 1 plus 2x plus j dou x. Here x is not there. So it will become 0. Here also z is not there. So this also will become 0. Okay. Plus k dou x. Here x differentiation is 1. So minus 2z. So minus 2z minus dou y. Y value is 1 minus x square. So here, if you take 2 common, you will get it as x plus z into I. Here if you take minus common, minus, if you take out minus common means x square plus 2z. Okay. So this is the answer for finding the del cross f. So even you have the problem to show that the vector is a irrotational. Means here whatever the del cross f value is there, here we got this value. If you will get that value as 0, then we call that vector function as a irrotational function. Okay. And one more problem is there. If function f is equals to function is given, then we have to show that f is irrotational and find scalar potential. Scalar potential function is there. And even one problem is there to show that function pi is equals to x square minus y square satisfies Laplace equation. So we have to show that this whatever the pi is there, it is satisfying the Laplace equation. So what is Laplace equation? Del square pi equals to 0. So del square pi means del dot del pi. Here whatever our pi is there, the pi value if you subscript, then we will get the answer. So we see this problem. So that the function y square satisfies Laplace equation. Okay. So we know that del square pi equals to 0 is Laplace equation. Okay. So del square pi is equals to del dot del pi. So del dot del pi means I dou by dou x plus j dou by dou y plus k dou by dou z. And what is our pi? And our pi is here x square minus y square. Okay. X square minus y square. So with respect to of this, if you do, we'll get it as that is this value is I into dou by dou x means it is 2x I minus y square means it is 2y j. Okay. Now del dot this one means again it is equals to I by dou x plus j dou by dou y plus k dou by dou z into 2x I minus 2y j. So this will be I by dou x of this will be 2. Okay. And j of dou by dou y means it is minus 2. Z is not there. So this value is equals to 0. So it is satisfying the Laplace equation. Therefore, del square pi equals to 0. So function pi equals to x square minus y square satisfies Laplace equation. Okay. Like this, we have to solve the problem.